A very good morning to you. You are welcome to this DVB Demos 2020 event. My name is Owen O'Sullivan and I'm at the DVB project office here in Geneva. Over the next just under 2 hours, we have 14 different exhibitors who are going to present some short, sharp demos to you of how they are implementing the latest DVB technologies. At the end of that, we will have our head of technology, Emily Dubbs, who's going to tie it all together for you and show how those technologies fit together. But before we begin, I'm going to hand over to the chair of the DVB project, Peter McCavick. Peter, good morning.
Good morning. Good morning, Owen. Good morning, everybody. And welcome from my side to this very innovative DVB demos. You're going to see over the course of today a combination of new announcements. You're going to see interoperability demonstrations. You're going to see a whole variety of different things, all focused on the DVB's work. Excellent work it is too over the last little while. It's COVID-19 time, so we're focused very much in an online format. This is a format pioneered by the DVB office, which seeks to replicate the experience that you would have at a trade show. So you hear and see things going on at the trade show, as you will do this morning. And then as you move through the day, you have an opportunity to actually meet with the various different exhibitors, learn more about their DVB innovations. And these innovations are not just about making new announcements, but it's also about the interoperability and the full value chain. Also, the joys of online means that these demonstrators are coming from around the world, from various different countries, and it's early or it's late, but the nice thing is it's DVB that brings them together. So I hope you enjoy this day. I hope you enjoy the format pioneered by the DVB office, and we wish you a very pleasant DVB Demos 2020.
Peter, thank you very much, and I know you'll be watching throughout the morning. And indeed, we should mention that among the rooms that you can book to meet our exhibitors this afternoon, we also have a room for the DVB project office. So whether you need to speak to the head of the project office, Ava Markford, or to Peter, our chair, or to Emily, our head of technology, we will be available. Just let us know what it is you need to discuss when you're making that booking. Peter, we'll talk to you later. So it's time for us to move on with our very first demonstration for this morning. We are going first to ATEM, where I hope that Thibaut is going to be waiting in a moment to talk to us about DVB Dash, streaming, low latency streaming, and so on. Thibaut, good morning.
Good morning, Owen, and thanks for the introduction. And again, thanks everyone for attending the DVB demos today. So I'm Thibaut from ATEM, and today I will present the demo we will showcase this afternoon in our dedicated Zoom session. And the demo is about low latency video services using DVB Dash. So first, let's see the problematic we are addressing with our solution. What we are addressing in this demonstrator are both the capability of delivering video services to multiple screens, including IP and broadcast, at a minimum delivery cost, and the capability of delivering a consistent quality across all the screen, especially in terms of latency. To illustrate that, you can see below an architecture addressing those problematics using an ATEM headend. On the left side, you can see the content originator, which could be, for example, a broadcaster or a service provider. On the right side, you can see the types of devices that are addressed, including, of course, all DVB devices, but also other types of Dash and HLS-compatible devices. And in the middle, of course, you can see the headend and the delivery path. So the content originator is delivering the video service to the headend for content preparation, and the headend is composed by an ATEM T2 encoder and packager that is carrying out a single or multiple bitrate encoding. The output video is packaged into both MPEG transport stream to address legacy broadcast, but also in low latency common media application format or CMAF. CMAF here is really practical because it enables to deliver a unified format compatible with all devices and all delivery protocol. The CMAF files include the Dash and HLS playlist and the associated ISO BMFF files. And of course, the produced Dash is created in a DVB compliant way and can be registered in a DVB-I service list as well. The produced CMAF is pushed to the Atom's origin server that is capable of delivering low latency services to IP clients through the Akamai CDN thanks to HTTP chunk transfer encoding. So in that configuration, Atom enables the broadcaster and service operator to deliver a quality consistent services to a large audience, leveraging the latest DVB technologies such as DVB-I and DVB-. Now let's have a look on what we are demonstrating today. What we highlight is how the Atom EDN can deliver quality consistent video services to both broadcast and broadband with a minimum latency and taking advantage of our advanced encoding, packaging, and origin servers. And this is illustrated in the scheme just below. First, the video source on the left is time-stamped before the HEVC encoding. The encoder produces low latency chunked elementary streams encapsulated in both CMAF and MPEG-TS. Of course, the MPEG-TS bitstream is directly delivered to professional IRG. The low latency CMAF is pushed to the origin server in a low latency fashion using chunk transfer encoding. And the Akamai CDN is pulling at the same time to deliver a low latency experience to the clients asking for the content. In terms of player support, we are able to demonstrate the stream on a wide range of players and clients, including GPAC, on-screen publishing app, which can also register the DVB- streams in a DVB-I service list, Dash.js, Shaka player, or vAccess Orca player. What we show in the end is the output decoding time of broadcast and OTT compared to UTC time, demonstrated an aligned latency between both. So first, before seeing clips of the demo, let's have an overview of what you could expect to see in a traditional trade show. Here on this slide, you can see a picture showing the demonstration setup we are proposing. On the left side display, you can observe the output of the broadcast IRD, which is our carrier receiver. On top right, you can see in the browser the Dash.js-based Akamai player playing the CMAF low latency Dash service. Just below, you can see in the terminal the current UTC time. If you actually have a look on the picture, you can see the latency of broadcast and broadband compared to UTC time. Actually, in that demonstration, you can see that broadcast and broadband are actually in the same range, even showing a small advantage to broadband. Now let's see some clips to this afternoon demo. In that video clip, you can have an overview of one of the things we will show this afternoon during our session. What you can see in that video clip is how the DVB- combined with DVB-I can be used to deliver low latency experience to a wide range of devices. On the left side, you can see the video service played in a Chrome browser using the Dash.js-based Akamai player. On the middle, you can see the vAccess Orca application playing the video on a Xiaomi Mi 9 smartphone under Android 9. Finally, on the right side, you can see how DVB services can be delivered to iOS using on-screen publishing DVB-I client embedded in Safari browser under iOS 14. More specifically, we will have a look on latency measurement and how a couple of seconds latency can be achieved for DVB- services on a standard Mozilla Firefox browser. In the video clip, you can see the Akamai player, which is based on Dash.js and which is capable of achieving a low latency playback. Once the player is triggered, the targeted latency, which is 1 second here, is progressively achieved. Here you can see the video on the left side and an overview of the buffering and latency information on the right side. In the window below, you can observe the current UTC time and notice that the achieved end-to-end latency reaches 2 seconds overall. So let's conclude now. What we are proposing and demonstrating in our demo this afternoon is how a broadcaster or service provider can deliver quality consistent video services across a wide range of screens, leveraging latest DVB technologies. The demonstrator is based on our Atom Tito encoder, packager, and origin server, enabling low latency video services delivery using DVB-, reducing the delivery cost and extended the audience reach. Finally, please join us this afternoon for the demo to see all the technical details, and don't hesitate also to have a look on our partners on Dvb Demos, such as vAccess Orca and on-screen publishing. Thank you.
Thibaut, many thanks for that demonstration. As you know, there are many different options when it comes to streaming formats. What would you say are the reasons for choosing DVB- specifically?
Well, we believe a DVB strength is to provide interoperability between equipments across all the value chain. By using DVB- combined with DVB-I, we've seen that we're capable of providing a consistent quality and low latency to any types of devices with a maximal audience reach in the same time.
Well, many thanks, Thibaut, and I hope that you'll have lots of interesting conversations this afternoon in our breakout rooms. Okay, it is time for us to move on. We are going from ATEM to our next exhibitor, which is Broadpeak, and hopefully I am joined now by Alain-Pierre Brunel, who will be talking to us about DVB multicast ABR. Alain-Pierre, good morning.
Good morning, Owen. Sure, yeah. So thank you all for joining this session. So we are really excited to participate to this DVB online demo event. And before we start the demo, let me introduce myself and Broadpeak. So Broadpeak design a video delivery component for content provider and network service provider deploying IPTV, cable, satellite, OTT, and mobile services. So our main area are first video CDN, cloud PVR, server-side ad insertion, and multicast ABR delivery. So the company is 10 years old and is based in Brittany, in Rennes. And I'm Alain-Pierre Brunel, training manager at Broadpeak. And our demo today is about DVB multicast ABR. So let's start now the demo. Hello. During this session, we will demonstrate low latency DVB multicast ABR using Broadpeak multicast ABR solution. So the Broadpeak solution is composed of a DVB multicast ABR server, that's the Broadpeak transcaster, and a DVB multicast gateway, the Broadpeak Nano CDN adjunct. Let's have first an overview of a DVB- low latency multicast ABR system. The DVB multicast ABR server, the BKE200, the transcaster, is fed with a DVB- low latency stream. Output from our BKS350, our origin and packager server. The DVB multicast ABR gateway, the Nano CDN adjunct, can receive the stream either from the unicast or the multicast path. Unicast from the origin packager and multicast from the transcaster. In any case, the gateway will serve the DVB- low latency stream to the consumer device using unicast. The playback can be done on any device that has a dash low latency player. Let's now review the testbed. So we have virtualized the server. We have one encoder, one dash low latency capable origin server that feeds the DVB multicast ABR server. One, of course, DVB multicast ABR server, our transcaster. Two DVB multicast ABR gateway. So here we are using Technicolor DSL home gateway with the Nano CDN adjunct installed on it. Two terminals. Each one is connected to its own dedicated gateway. For the demo, we will be using Samsung Galaxy tablet. In addition, we have one PC that is here to monitor the traffic and to see the difference when using unicast and when using multicast. For the demonstration, we will be using the player provided by our partner, ViaccessorCar. This player is fully integrated with the Broadpeak solution and is dash low latency compliant. I'm selecting the URL. So the two players have initialized a unicast streaming session directly with the origin packager server. The monitor shows that the terminal consumes the bandwidth corresponding roughly to 2 times the video bitrate, that is a bit more than 3 megs. We activate now the multicast ABR on the network. And now we see that the DVB multicast ABR gateway are fed using multicast. The two players continue to stream seamlessly the session. The monitor shows that the bandwidth consumed by the two terminals now is twice less than using unicast. The latency remains the same after unicast to multicast switch. We see here a latency about 4 seconds between the encoding and the decoding on the device, which is less than what you get using IPTV. As a matter of fact, low latency streaming is much more reliable when using multicast ABR than using unicast ABR, as multicast distribution on the network is controlled by the operator. Thank you for viewing our demo. Broadpeak is proud to contribute to the DVB multicast ABR standardization effort as the early inventor of multicast ABR technology, sharing a unique experience of 5 years of development and serving today several million of end users. Our agent is implemented in more than 100 different physical boxes and deployed in 15+ networks in the world. More than 6 million homes have a nano CDN agent in their gateway today.
So, Alain Pierre, many thanks for that demonstration. Look, it's clear that Broadpeak has a lot of experience already in multicast and multicast ABR, but I know you've also been contributing heavily to the standardization efforts within DVB. Tell me, where does that instinct come from? What do you think are the benefits of moving to a standards-based approach for multicast?
Yeah, so as you have seen in the video, Broadpeak see the benefit of using multicast ABR distribution for many years now. However, we won't be able to make this happen and alone, and we need some partner and also some competitor on the subject. So joining DVB Group to create a standardized solution is the best way to promote multicast ABR. So to me, DVB is the key to expand multicast ABR popularity. I will add something more. So for the one who would like a feedback and information on real deployment using multicast, I will be sharing a link on the YouTube stream. This is a testimonial of operator that already deployed feedback so that you get what they see with that.
Many thanks. We're very happy to have Broadpeak on board in the DVB project. Talk to you again, Alain Pierre. So, time for us to move on. That's 2 of our demos done already. And now it's time for us to go to Dolby. I hope that I have Jan Muller waiting, and he's going to talk to us a little bit about some of the exciting new possibilities that DVB-I opens up. Jan, good morning.
Hello, Owen. Good to see you. Okay, so hello to the audience. My name is Jan Müller, and I'm working for commercial partnerships with Dolby with a focus on streaming media standards. One thing that is really interesting for me right now are the engaging opportunities of DVB-I for broadcasters to use the standardized internet delivery of exciting new media technologies. For consumers, how easy the usage is and how well it can be integrated in TVs. Our key message focuses on launching enhanced audio-video services. So this certainly means the big improvements on video like 4K, UHD, and high dynamic range video. But it also says for immersive and personalized experiences. So what does that mean? So when I say immersive and personalized, I'm thinking of an ongoing revolution of the audio technologies called next generation audio, or in short, NGA. NGA, and by the way, Dolby's solution for NGA is called AC4, is a new audio standard that brings new listening and completely new audio control experiences to the users. But what are these words saying? So immersive means audio coming from all 3 dimensions, with audio even coming from the top. So imagine what that means. Being in the middle of a thrilling action movie or a realistic documentary or the exciting feeling of the sports arena. So personalized means audio becomes interactive. Users can tailor their individual audio experience exactly to their own preference or have the right access to the content. So today, I want to show you how an internet-delivered UHD AC4 service can be well integrated in the regular demo application. For this, I will use a Philips Smart TV off the shelf that can reproduce this immersive audio experience with its built-in loudspeakers. So, however, unfortunately, we will not be able to transmit this immersive experience also over to you here today because of our webinar platform, but I will try my best to describe it. So let's have a look at my TV.
We are in the home screen of my Philips Smart TV. I want to show you that a UHD AC4 service is present within the regular DVB channel list. We want to watch linear TV, so the only thing I need to do is to press the TV button on my remote. Now we are in a channel of a public German broadcaster that comes in via DVB-S satellite connection here at home. When I open the channel list, you can see a few more channels that are all coming in via satellite, but I want to particularly highlight one here that is called UHD Dolby AC4. This one comes in via internet through DVB-delivery. So I'm going to switch into this channel. And once the stream is there, I immediately see the difference. This is excellent 4K UHD video. And the audio is not just on screen. I feel if I would be in the middle of the scene. These realistic audible events around and on top of me really make a huge difference for me to the flat stereo or even traditional surround sound experience.
So you have seen how well integrated such internet-delivered enhanced audio-video service can be in the regular channel list of the TV. So now I want to show you how we think upcoming implementations of DVB-I clients could look like that also integrate the audio personalization feature so that users can tailor the individual audio experience exactly to their own preference. Let's have a look.
We are in a DVB-I streaming service with sports content. I'm opening the audio personalization menu. Visually impaired users can turn on audio description that comes with a balance control. Depending on the playback environment, users can turn on or off the automatic loudness control. Showing some further sound modes, I want to particularly highlight one that is called Dialogue Enhancement. Dialogue Enhancement is improving the intelligibility for everybody by prioritizing the dialogue. Users can select their preferred language, which in this case would apply to the sports commentary. Further, users can adjust the whole audio experience. Imagine you could be on the track and have a very close experience like a cameraman. But you could also choose the full immersive experience like you would be on the terraces, with all the crowd noise around you or the PA coming from the top. But you could also choose the opposite, by just having the commentator and feel like you were sitting right next to him in the commentary booth.
So altogether, you have seen the great opportunities of DVB-I with NGA using Dolby AC4. In the first video, I've shown an internet-delivered UHD AC4 service within the regular channel list of the TV using DVB-I delivery. So in the second video, I've shown our vision how a DVB-I client could look like that implements the audio personalization feature so that users can adjust their individual audio experience. So many thanks for watching. And I'm really looking forward to see some of you in the afternoon meetings later today. So get an appointment and come around and let's talk about that again. For now, back to you, Owen.
Thanks, Jan. Really interesting stuff. Of course, we know that Dolby does great things around next generation audio, immersion, personalization. My network is gone. There we go. Jan,
think
are you
you're
hearing
back.
me? Yeah.
Yes,
Can
I think
you
you're
tell
back.
me, I just had a question for you, which is in terms of these exciting possibilities, personalization, immersive audio, can you tell me what is it that DVB-I specifically opens up in terms of possibilities?
Yeah. So I think the great opportunity right now of DVB-I is the quick and easy path to launch, for example, trial services using these enhanced audio-video technologies. So using DVB standardized internet delivery to address the existing receiver capabilities out there in the field is a very cost-effective way of doing experiments or launching trials right now.
Good. So we're going to be hearing a lot more about DVB-I later on as the day goes on, but already that's one very good reason for looking more closely at DVB-I. Thanks for joining us this morning, Jan.
Thanks, Owen.
So time for us to move on with our next exhibitor this morning. From Dalby, we go to ENENSYS, and I'm going to be joined by Eric Denio, who's going to have two demonstrations to show us. He's going to be talking to us about DVB targeted advertising and also about DVB multicast ABR. Eric, bonjour.
Bonjour, Owen, and thank you for the introduction, and good morning to everybody. Welcome to the ENENSYS booth of this DVB Demo 2020 event. The first demo our teams have prepared is about our targeted advertisement solution named Ads Reached. This one has been designed along the lines of the DVB-TA specification, and it works with commercially available HBB-TV-enabled TV sets. Let's have a look at it.
The advertising market is shifting towards more and more targeted models, largely relying on the possibilities offered by digital platforms. As TVs are now widely connected to the internet, broadcasters are looking into addressing their audience with targeted advertising and thus increasing their ad revenue. In that sense, DVB has worked on a common technology stack defined in the DVB-TA Blue Book. DVB-TA is designed for the HBB-TV ecosystem and the HBB-TV-TA standard, which indicates how to implement dynamic ad substitution on connected TV sets with accurate synchronization. ENENSYS Ads Reached solution enables targeted advertising in regards to the DVB-TA guidelines by inserting overlay banners or by substituting ads dynamically from the broadcast services. Now, let's have a look at what a dynamic ad substitution looks like. During the ad break, one or several spots can be substituted from the national broadcast in order to better target the viewer. When a spot must be substituted, the TV set will receive an HBB-TV stream event converted from SCOTI35 following DVB-TA guidelines. The TV will then make a request to an ad server, which will then dynamically choose the right spot to display for this TV receiver, depending on its viewing habits, for example. As you can see, the substitution is seamless for the viewer. In fact, the spot is downloaded from the CDN as a background task on the TV, and it is displayed when it is the right moment. When the spot ends, the TV can then switch back to the broadcast content. An accurate substitution is only possible with accurate signaling, indicating when the substitution must happen. To handle the signaling, ENENSYS Ads Reach solution includes a product called MediaCast Ads Reach. As you can see, the MediaCast includes a DVB-TA mode, following the guidelines defined by DVB. You may also notice another mode available when HBB-TV and DVB standards are not applicable. TV remains the most powerful media and the only media to address millions of users simultaneously, and targeted advertising powered by ENENSYS Ads Reach allows broadcasters to increase their ad revenue. While HBB-TV-TA and DVB-TA are being deployed, targeted advertising can be enabled today with Ads Reach and for the years to come.
After targeted advertisements, my colleague William Stovar will now demonstrate our multicast ABR solution. This one is fully compliant with the multicast ABR standard, and it integrates interoperability with third-party products. I won't say more. Let's start the demo.
Video live streaming is thriving. Comcast recently announced they have lost almost 300,000 paid TV subscribers, while their Peacock TV OTT service registered 22 million sign-ups. This fantastic growth challenges CDN capacity. Inappropriate CDN scalability management could lead to subscribers' bad quality of experience and churn. Additionally, network operators need to organize for multi-sourcing their infrastructure to reduce risks and optimize costs. But multi-sourcing leads to concerns of interoperability between different providers. DVB Multicast ABR offers a standardized framework for delivering streaming video services using multicast to ensure high-quality network scalability and vendor interoperability. ENENSYS Technologies is announcing today the world-first DVB Multicast ABR interoperability between Soft-at-Home Multicast ABR Gateway and ENENSYS Multicast ABR Solution Suite. The ENENSYS MediaCast Controller enables operators to easily schedule multicast ABR services from a DVD-stream source through its GUI interface, while the ENENSYS MediaCast Broadband ingests the dash-stream content and encapsulates it into the DVB Multicast ABR Flute protocol for multicast transmission towards subscribers' homes. Multicast content is received seamlessly by Soft-at-Home Multicast Gateway or ENENSYS Cube Agent, then converted into unicast, so end users enjoy flawless live video in any of their multiple devices.
With the first partnership with ENENSYS, we are demonstrating Soft-at-Home interoperability with a DVB standard multicast server. With DVB standardization of multicast adaptive streaming technology, Soft-at-Home has decided to focus on LAN video quality delivery.
ENENSYS Multicast ABR solution enables operators to create scalable multi-screen video services with high quality of experience, generating new revenues in a multi-vendor environment.
So if you want to see more and know more about our products related to multicast or to targeted advertisement, do not hesitate to take an appointment to meet our team this afternoon. We have 2 rooms, one dedicated to each of the solutions, and we will welcome all of your questions and all of the things we can offer you. Thank you for your attention.
Eric, thank you very much for those 2 demonstrations. We know that DVB is moving towards very much an IP-centric view of the world. Tell me, how is ENENSYS positioning itself for that shift?
Well, in fact, ENENSYS has been anticipating this shift since the creation of the company 15 years ago. We've designed our first IP gateways back in 2006, and we've sold thousands of them. We've been shipping software products for many years now, and we've deployed software virtualized headends with several of our customers. We clearly believe that the SaaS versions of these products is the future of broadcast. And in a way, the hybrid broadcast broadband architecture of the ads-rich solution is a move in this direction. Also, the multicast ABR solution is our ultimate answer to this IP-centric move of broadcast.
Great. Well, it's been great having you with us this morning, Eric, and I hope you have lots of good conversations in the meeting rooms this afternoon. Talk to you again.
Thank you, Owen.
So, time for us to move on. We're a tiny bit behind time, but that's okay. We'll keep rolling on. Next, we are turning to our next exhibitor, which is Google. And I'm going to be joined by Milton from Google, and they're talking to us about Android TV. Milton, good morning.
Good morning, Owen. Thank you. So I'm Milton from Android TV partner engineering team. Excited to be here in the virtual demos. So while we are still transitioning to the IP-based future to reduce complexity and integration effort, Google is making it even easier to develop traditional broadcast TV devices. So a quick intro on Android TV. Android TV is Google's operating system for smart TVs and set-top boxes. It's a platform which brings all media together in one place, from live TV to on-demand gaming and other forms of entertainment. Our goal is to provide a best-in-class OS for panel TVs, streaming devices, and hybrid set-top boxes. It is full stack, royalty-free, and we provide the flexibility to fully customize and integrate with any technology. So it includes voice assistant. So we're bringing Google innovation to the living room, revolutionizing the TV experience by putting your device at the center of the smart home. Android TV is available across a range of devices. We have retail devices, smart TVs, streaming dongles, and other streaming devices. And we have hybrid set-top box and OTT devices from operators. And wanted to mention that Android TV can help you migrate to the future with ease. Partners can already develop OTT app on top of widely used Android TV app infrastructure. With operator tier program, operators can develop their custom user experience. And now Android TV is making the traditional broadcast tag middleware available for free to its partners to make the transition even easier. There's been a huge momentum. 7 of top 10 smart TVs have adopted Android TV, and more than 170 operators in 60 markets have chosen to build their pay TV devices based on Android TV. A quick intro on the common broadcast stack. The broadcast stack is an essential component of smart TVs and hybrid set-top boxes to provide digital TV broadcast services to users. It has been one of the top requests from our partner community to include it as part of Android TV offering. To demonstrate our commitment to broadcast TV, we're introducing a common broadcast stack. We have acquired it from a vendor that is already widely ported and productized. The main benefit of common broadcast stack is that it will make it easier for our partners to integrate Android TV. It will reduce total cost of ownership and time to market. It will be provided to our partners in source form, totally free of charge. Partners are free to add differentiating functionalities on top. The only restriction is that it can only be used on Android TV devices. In terms of kind of features, it supports major broadcast protocols, including all the DVB variants, comes with basic IPTV and PVR features. And from the roadmap point of view, we want to focus on these 3 main areas. First and foremost, we want it to be easy for our partners to integrate Android TV. And to that end, we want to further reduce complexity by pre-integrating the broadcast stack with some of the associated components like conditional access solutions, HBB TV. And then secondly, we want it to be an exemplar. So we want it to be, we will make sure that the broadcast stack is aligned with all the architectural changes. And thirdly, along with their extensive test suites and test tools, we want to focus more on testing of hybrid functionalities. Saying that, I'll show you a few demos. So this is kind of demo with very basic integration of broadcast stack. This showing the basic channel scan. One of the things about the broadcast stack is that it is developed from the ground up for Android TV. So it is fully aligned with Android TV architecture. There's channel rescan here. To continue the thread, Google will maintain the broadcast stack in collaboration with the Android TV community. It will be a great opportunity for us to collectively improve the quality. Wait for this clip to finish. This shows trick play demo. These functionalities are available as part of the broadcast stack and is configurable. It is architected to incorporate product-specific custom configurations. It is also easy to add custom features. A quick demo of closed captions. And basic recording functionalities. This is included in the common broadcast stack. So this is fully TIFF compliant. That is TV input info framework. The intention is to expose the capabilities from broadcast stack to the TV app. On the top, more project-specific rules and policies can be developed in the TV app, which sits in the application layer and will include the user experience and implement business rules. So that was all. For more questions, please reach out to this email address, or we can talk in the afternoon. Thank you. Back to you, Owen.
Many thanks, Milton. Thanks for being with us this morning. Google, well, as you know, DVB has been around for more than 25 years now. Google joined us within the last 2 years. We were very interested to have Google on board, but can you tell me what, in brief, what was behind that decision for Google to join the DVB project?
Sure. Thank you. Thanks for the question. So as I kind of mentioned, touched upon it, so we're seeing a huge momentum. So 7 of top 10 smart TVs have adopted Android TV, where 170 operators in 60 markets have chosen to build their pay TV devices based on Android TV. So DVB is an industry consortium. Google joined DVB because we're keen to learn from industry experts. But it also gives us the opportunity to work with others to get to the future of TV. So you know that our partners are relying on us. They want to work with us to get to the future. And DVB is the kind of right kind of place where we can work with our partners and the industry to help create that future of digital TV and broadcast TV.
Great. Well, we're very happy to have you on board, Milton, and thanks for joining us this morning. And a reminder to everybody that if you would like to talk to Milton this afternoon, you can book time now. Just go to, you need to get your Zoom link, and then you will have a link also to a schedule where you can book time with Milton and with all of our other exhibitors. Next, it is time for us to go to Harmonic. I'm going to be joined by Patrick Gendron, who will be talking to us about the use of DVB-I in a of the use of DVB- in a DVB-I environment. Patrick, good morning.
Good morning, everyone. I'm Patrick Gendron. I'm Innovation Director at Harmonic. Harmonic is happy to be part of this DVB Demos 2020 event. Our presentation this afternoon will illustrate a full digital ad insertion workflow using DVB- in a low latency environment. And because we believe these are complementary technologies, we will show both server-side content replacement and client-side banner insertion triggered by server decisions. Harmonic will showcase how its VOS 360 platform integrates into a full IP DVB-I environment. Our targeted ad insertion solution offers an end-to-end OTT workflow from the playout to the player in DVB- with low latency for enhanced viewing experience on every screen. For this demonstration, we have been working with the accessor card on the player side. Going one step further in the demonstration description, we will show the various elements of the workflow. From the playout, scheduling the ads events through a simulated ad server connected to the manifest manipulator. This manifest manipulator serving a personalized manifest to an OTT client. We will also show how this content replacement can be mixed with personalized banners or other graphics inserted client-side based on server decisions. Finally, we will show how we can optimize this workflow to support the additional constraints brought by the low latency feature. This presentation has therefore 2 main parts. We will first describe and show the end-to-end workflow for targeted ad running on the SaaS mode running our VOS 360. Then we would like to give a preview of Harmonic solutions for targeted ad insertion in low latency dash workflow, where we know that some evolution are needed to cope with more strict timing constraints. Let's have a look now at a short video of the type of experience you can get on a player. Here we start on the main content delivered by the playout. Then we have a 2 slots ad opportunity. The first slot is marked as replaceable and is then replaced by the ad server with a targeted ad. When the targeted ad ends, we move back to the second ad coming from the playout. All transitions are made frame accurate. And at the end of the second ad, the playout moves back to the main content. The logo that can be personalized is inserted by the client, but this can be triggered by the server. Similarly, the targeted banner insertion can be made client-side with a trigger sent by the server. So, to summarize, this afternoon, we will show an end-to-end DVB digital and insertion workflow. This presentation is made in collaboration with the accessor card when players support the multi-period scheme. We will illustrate how digital and insertion can be combined with low latency for sport events. And last but not least, finally, this should be seen as a preview of a DVB targeted ad service in a DVB-I environment. To see more, come to visit Harmonic in our breakout room this afternoon.
Patrick, thank you very much for this demonstration. Tell me, what you've shown us there, of course, is not purely at this point a DVB-TA approach. How do you see this setup evolving towards being a fully DVB targeted advertising approach?
Yes, indeed. DVB started the DVB-TA work on the broadcast type of application with client-side insertion in connection with HbbTV. But DVB is starting to work on collecting requirements for to move this DVB-TA in a full DVB-I environment. And definitely Harmonic is committed to contribute to this very important work on this space.
Good. Indeed, anybody who is watching the stream and would like to get involved in that work, if you're with a DVB member company, you can jump straight into it. And if you're not a DVB member, it's very easy to join and get involved in the work. Patrick, thank you for joining us this morning. So time for us to move on from France. We are going to Italy, where we are going to be joined by Kineton. I should have Riccardo Sabatini on the line here. Ricardo, good morning. You're going to be talking to us about DVB-I.
Good morning, Julian. Thank you. Good morning, everybody. I'm Riccardo Sabatini, and I'm a software developer at Kineton. Kineton is an IT company based in Naples, Italy, which operates in different fields. Today, I'll be representing the media and telecommunications section. Kineton is a member of different organizations that deal with the definition and promotion of standards and references, both in the broadcasting and in the advertising areas. Being a member of DVB actually allowed us to witness the birth of one such standard, DVB-I. So today, I'll be showing you the result of our work in this direction. This is the Kineton DVB-I management panel. The idea behind this platform is to have a central place for all broadcasters to maintain their service lists. Every company can access the panel using one or more accounts, each one with permission to different or limited functionality and information. So you can have, for example, an editor role, which could just create and edit lists, and a publisher role, which would supervise these operations and verify the validity of the service lists, and then proceed with publishing. Let's move on to how it actually works. If your company already has an XML file for service lists, you can upload it, and the platform will take care of all needed validation for you. So once uploaded, it will just check if the XML file is well-formed and complies with the DVB-I specification. It will then proceed to a second stage of verification. It will check if the dash streams are valid or if satellite data is meaningful. Once uploaded and verified, the service list will be available on the platform. Now we get to the key point of our platform, which is the creation and modification of service lists. With our simplified user interface, the user is guided step by step through the creation of a service list. So you can define the service list name, the provider name, the version, which is automatically increased in case you're editing an existing list. And of course, you have the services. Services can be added to your liking, and you can define the properties, and each service has different service instances. Each service instance can be a different source type. So you could mix, for example, dash streams with satellite data. As you can see, it's easy to modify. And then you can save. And the platform will proceed. The platform will generate an LCN table for you, which you will then just have to fill with your assigned LCN numbers. Once you're done with the list, you can upload it to the platform, and it will be available in service list, or you can just download an XML file, a fully compliant DVB-I XML file. Here, I'll submit it to the platform. Okay. So the last section is only available to supervisor organizations, as it allows to merge all the selected service lists by the broadcaster organizations. So you can select the ones that you want to merge. You can provide a service list name, provider name, a version number, of course. And then again, you can download a fully compliant XML file, or you can submit it to the platform, but this time it will be publicly reachable, so that the compliant DVB-I clients or devices can actually consume the service list. So this is our platform. It is intuitive, so that everyone can use it, even small companies that don't have the knowledge of the DVB-I standard, but it is also powerful, as it allows different levels of control and publishing capabilities. Of course, if you have any suggestion, we'll be glad to hear it. Thank you.
Ricardo, thank you very much. It's good to have Kineton with us this morning, showing us the possibilities of DVB-I. Italy has for a long time been at the forefront of efforts to integrate broadcast and IP with a long history on MHP and HBB TV as well. Are we going to see that trend continuing with DVB-I in Italy?
Yeah, I guess so. Since just recently, a reference specification called Ultra HD Book 2.0 has been approved, and DVB-I has been included in this specification. So devices on the Italian market starting from 2022 should all have DVB-I as a standard. And also we're seeing that many big broadcasting companies are showing interest in this standard. So we as a company believe that Italy will be one of the earliest adopters of this standard at a national level.
Well, that is really positive to hear. So from about 2 years from now, we'll see DVB-I as standard in the consumer market in Italy. That's great to hear. Thanks for joining us this morning, Ricardo. Now, we are staying with DVB-I for the next exhibitor, who is On Screen Publishing. Gordon Maynard is joining me from the UK. Gordon, good morning to you.
Good morning, Owen. So, On-Screen Publishing is a consultancy specializing in data management tools and multi-screen apps. We're the developer of On-Screen Publisher, a platform for easily creating apps for HBB TV, smart TV, tablets, and mobile. And what we're going to show today is an end-to-end platform we've created for demonstrating and evaluating and launching multi-screen services using DVB-I. We see DVB-I as an exciting development, building on existing DVB standards to allow viewers to enjoy a familiar TV experience, whether in a hybrid or IPTV only environment. DVB's use of metadata and client apps fits well with our products and experience, allowing rapid development of a flexible DVB-I platform. Our platform is built around the three main DVB-I data sources, and behind that we have a management system with a powerful user interface, allowing these data sources to be created and managed. We also have tools for importing data from external sources. Just add video streams. On the client side, we have web applications for HBB TV and for generic tablets and mobiles. We also have native Swift apps for Apple devices, Apple TV, iPad and iPhone. For building evaluation platforms, we also have a capability to process transport streams, creating an environment where DVB-I is integrated with broadcast. So let's see how this might be presented to viewers. Here we have an HBB TV application superimposed on a broadcast stream. Channels are selected from the list on the right, delivered by DVB-I metadata. Channels can be selected also by channel numbers. Each channel has a number of instances, in this case terrestrial, satellite and DVB-, where we're playing a stream to emulate that. We can offer a similar experience on tablets and Apple devices, but without the broadcast option. Returning to the HBB TV app, we can see the TV guide that's driven by DVB-I data. It can also be merged with off-air EIT data. This guide supports full program information and also allows programs to be selected and then click through with a deep link into a catch-up service. We can also use the same data to create a similar experience on other devices, here a native iPad and an Apple TV receiver. Back on HBB TV, we can look at the service list discovery process, one of the most innovative parts of DVB-I, where viewers can be offered a list of service lists, potentially from competing operators. Earlier we had a Freeview UK service list selected, which we can now delete. And we can now use the menus to drill down through the other service list offerings, in this case selecting a list based on Australian channels. Returning to the main screen, we now see Australian channels, but with all the regional variations. But DVB-I includes regional filters, allowing services to be selected appropriate to a region. So here we enter a Canberra postcode, and if we then return to the channel list, we only see the appropriate channels. We support this service list selection across all our app types. Here we're using the same data, but on an iPad application with a familiar Apple look and feel. All of these demos are powered by our Metadata Manager. This provides editing and management screens for all the major DVB-I content types. Here we've got lists of services which are grouped by provider, and you can click through to see the service instances, here based on the BBC example we showed earlier. Services and service lists are grouped together to provide the drill-down interface that allowed the user to select the service list. We also have management tools for content guides, and there can be different versions of this for different services on different networks. We also have schedule management and program management. The Metadata Manager feeds this data out as XML, so you never have to edit the XML files that are required for DVB-I. Our DVB-I platform is available now for testing, evaluation and demonstration of DVB-I. The Metadata Manager can form the basis of a data generator for DVB-I integrated with existing sources. The apps are ready to be completed to meet the needs of operators or used as accelerators to add DVB-I functionality. We can also offer strategic and technical consultancy services based on what we've learned building this platform. Thanks for listening. If you'd like to learn more, either arrange a meeting or visit our website. So that's just a brief run through of the capabilities of our DVB-I platform, and I'll look forward to speaking to some of you this afternoon, or if you contact us at any
Gordon,
time.
thanks very much for being with us this morning. The platform that you've just demonstrated there, how do you see that being used in the short to medium term?
Well, DVB-I is an emerging technology, and I think DVB-I answers a lot of questions that people will have about how broadcasting can move into a fully hybrid environment. So the time is right now, I think, to be evaluating and testing and trialing DVB-I. And we're very keen to work with broadcasters, platform operators or regulators to help them understand how DVB-I could be deployed in their markets.
Great, thanks Gordon. And of course all of those people, if they are interested, can meet with you this afternoon in our meeting rooms. So do get on and book your session with Gordon for this afternoon. Now we're staying somewhat with DVB-I for the next section, but just as one small part of a much bigger overall offer, because we are going to the OTT Broadcast Consortium. Now we're going to start this with a little video that has been prepared by the OTTB Consortium, and then we'll come back and hopefully we'll be talking to Alan just after this.
Hi, my name is Alan. I'm from Media at Hand, representing the OTT Broadcast Consortium. I'm here to present the concept behind the OTT broadcast specification and to give a little introduction to the world of OTT streaming and broadcast. As this presentation is part of the DVB Demos 2020, I will put a special focus on how we have integrated different bits and pieces of the DVB standards into our specification. You cannot say DVB without thinking broadcast, and broadcast technologies has really over the decades given us a lot of stable, high-quality content reception without the typical hiccups the early OTT streaming services were struggling with. Also, broadcast has given us access to more than 1,000 live linear TV channels to zap between with just a simple installation of beautiful reception furniture to be put on our houses. Well, bad example. Talking of OTT broadcast, we could start by defining each of the domains. Here goes. Using traditional broadcast can be compared to using an ideal railroad infrastructure, and OTT is more like the roads. The train is always on time, it always fits the same number of passengers, and you know exactly when to expect it, but it's not very flexible. The roads, on the other hand, give the ultimate freedom with any type of vehicle suiting the task given. But on the road, traffic jams often occur, making it difficult to guarantee just-in-time delivery. Again, a lot of tricks exist for the roads to get people from A to B, but it will still be with best effort. So by combining the best of the two worlds and by adding native IP to the broadcast ecosystem, we suddenly open for whole new services for both old and a new generation of stakeholders to be part of. This is the essence of OTT broadcast. Enough talk. Let's see some demos. The demos are operational in the Copenhagen testbed, and here's a little video explaining what this testbed is all about, and then for the demos.
Alan, joining us from Denmark. Thanks for being with us this morning. Look, it's quite an ambitious ecosystem you're putting together there with your colleagues in the OTTB consortium. You could have used a whole bunch of proprietary technologies there, but you've really focused on using standards and international standards. Why is that? What's the importance of standards in this ecosystem?
First of all, you can say that the OTTB broadcast consortium here, we're a bunch of happy engineers here trying to build the stuff and make it work, right? And we're not trying to reinvent the wheel. And we do think there is a lot of need of different kind of standards in all parts of the ecosystem. But what we've done is that we kind of like took the best of the different kind of technologies here put together and see if we can make an ecosystem that has the more OTT feeling to it, because we come from the OTT world. And as I say in the demo, we do have some shortcomings in OTT. So we saw the great opportunities in putting IP over broadcast, because we could give us the managed network we are missing in our ecosystem. And that's why we said DVB has kind of a lot of good standards already. And what they've done is with the DVB-I, as we're demonstrating, we said that's a perfect ingestion format, because before we had to take the feed from one place and the metadata from another place put together, we suddenly have a good ingestion format. IP over satellite, terrestrial, cable, whatever. Perfect standard. So we added that to the ecosystem, and then we tried to put together something that works and is of course ready for the market to kind of be implemented. But for the demos here, we had to of course also make some user interfaces. So what you see here is actually stuff working, and not just a canned demo, even though it feels like it. It's actually stuff working. And this afternoon, I really want to walk it through with the people interested in how did we do it, how do we make it work, because it's talking over the demos here didn't really make sense for us. So as you can see, it's very ambitious, but it's demonstrating that it works.
Good, and I encourage people, if you are interested, I know for sure, for example, people might be interested in seeing what you've done with DVB generic stream encapsulation there as part of that environment, as well as the new stuff, DVB-I. And we know that the native IP work is well underway within DVB now as well. So I know that many of the members of your consortium are also members of the DVB project and will be getting involved with that. Thanks for joining us this morning, Alan. Now it is time to stay with DVB-I. And joining us from Finland, we will have our colleagues from Sofia Digital, who have been involved in building the reference application for DVB-I. I have Juha Joki joining me. Juha, good morning.
Good morning, Owen. So it's really nice to be here, and thank you for having Sofia Digital here in the DVB demos as well, although we are not even DVB members yet. So here's a little outline of my presentation. So briefly about the Sofia Digital company, and because we are such a small company, so probably not everyone knows us yet. So let's go. So we are established in year 2000 in Finland, and we have around 25 employees. And since our establishment, we have been focusing on TV service management tools, automation, and value-added services. And as said, we are based in Finland, and the company is owned by employees and our board members. And about today's topic, which is the DVB-I, and we have seen some great demonstrations about this already, but our company's role was to build a DVB-I reference application, which is a development of an open source reference application for Android devices and HPBT receivers, and specifically also supporting the operator application specification under HPPTV. And everything we have done under this project is licensed under MIT license, and all information is available easily from the DVB website. And you can go to the main page of the website and find it easily from the DVB-I section there. The reference application includes all the major features of the metadata specification already, and also some DRM examples. It supports Dash.js and native players of the TVs. And for the Dash.js, we have implemented low latency settings and statistics for the low latency performance and other statistics as well. So it's a great development tool. And in addition to that, it is designed so that it can act as a basis for any commercial projects or POCs. proof of concepts. The DVB-I reference application consists of both backend and frontend elements, so the backend can be used to create your own service lists. And our latest features include availability windows, regional service list, radio services, parental ratings, linked applications, accessibility, audio, and so on. So I really encourage you to check it out. And we have a lot of reference application service list examples. So there is a default list, which includes services from Akamai, Harmonic, IAT, and others. And DVB DAS reference streams, which are put available by the DVB itself for testing various features of the DAS specification. And of course more. So you can create anything you want using the backend that we have provided. And the exciting thing for today is that we have implemented and integrated the AID Playout Center German free-to-air service list, which was provided by Rundfunk Berlin-Brandenburg, and it's being demonstrated here with our technology partner Panasonic TV. So Panasonic has a really great operator app implementation, and we have integrated it with there. So it has all these great features, including full TV anytime EPG data with preview pictures, link to XML AIT services for launching applications for example, German MediaTek applications that are already available. So this can be utilized there. And I will now show you really briefly how it looks like on a TV. So yes, just a moment. So here you can see the HPP TV version. It's running obviously on the emulator, and you can see that you can switch between services. We have a couple of services available that are not geo-blocked for this service, and I can access also the EPG data. And it loads the complete EPG data for the service, and we can have the preview pictures there, so it looks really good. And in addition to this, there is the this is the Android version of the same thing, so we can have the same things happening here, and since this is designed for the mobile devices, the user interface is a little bit different. So this is how it looks like, and also then you can have a live demo when you are booking up in the afternoon sessions, booking up private session with our company. So let's get back to the presentation. And in addition to the reference application, we have, of course, been working on our own product, which is called Sophia Backstage for DVB-I, and it already supports all the features that are part of the DVB-I specification. So you can create service lists, create TV guide data, have service instances, defined service logos, and so on. So everything is already available as a commercial product and also in the reference application backend. So please take a look. And if you want to have more information about our demonstrations, our products, what we are doing, please book a live demo in the afternoon sessions. We will be showing the same using the real TV, Panasonic TV with operator application APIs, and also Android devices. We have different service list demos, and we can show off our Sophia demo set, which is a collection of everything that we have done in the HPP TV and DVB space during the past couple of years. So thank you.
Well, Juha, thank you very much. That is exciting news about the new collaboration with RBB in Berlin. Of course, Sophia Digital probably knows more about this specification than most other companies, having built that reference application that is there for everybody to use. A reminder that is on dvb.org/DVB-I. Can you tell me, when you talk to your clients and you're talking about DVB-I, what do you see as the main benefit, the main selling point of DVB-I?
Well, a lot of our customers are operators and broadcasters, and for them it's really important that you can combine your broadband and broadcast offerings in a single and standardized way, and which is proven to be implementable and working on many devices. As we heard before, that this specification is really gaining traction, and we are happy to be a part of it, and we hope that our effort here is helping implementing in this specification and making it better and foolproof, as you say.
Great. Well, thank you for being with us this morning, Juha, and I hope that you have lots of interesting conversations this afternoon in our meeting rooms.
Thank you, Owen.
So we are staying with DVB-I for our next contribution, which is coming from TPV Technology, TP Vision. Nicholas Frame is joining me. Nicholas should be online here. Nicholas, good morning to you.
Good morning, Owen. So yeah, welcome everyone. So my name is Nicholas Frame, standardization engineer with TP Vision, a subsidiary of TPV Technology, best known for manufacturing and designing Philips TVs. So in this demo, we're going to be discussing one of the main advantages of DVB-I, which is its ability to combine broadcast and broadband services into a single linear TV service offering, so carrying on that topic. So for this demo, we'll be using the following setup. We have a production Philips Android TV that's running prototype software that has native DVB-I support. We're modulating some DVB-T2 services locally. These have been kindly provided by Mediaset, with whom we've been working on testing and prototyping DVB-I. Mediaset have also provided us with a couple of DVB services. These are created by taking output from their production head end and feeding that via SDI into a DVB encoder. So those are live production services. In addition, we have some demo DVB services from additional DVB members, such as Harmonic, Dolby, and Broadpeak. The DVB-I service list that we'll be using is also hosted in the cloud, and the TV will be discovering that using a response to a service list registry query that's stored locally on a USB drive. That's done for test purposes. We could also have done a query to a live service list registry, but yeah, for test purposes, we're doing that locally. So now let's get into the live run-through of the installation process, and then we'll also show the viewing experience. So as I mentioned, we're combining terrestrial and DVB services here. So for a terrestrial installation, one of the first choices is the country. We've been working with Mediaset, so logical choice is Italy here. So once we've chosen the country, we choose the medium and get the terrestrial scan started. So here the TV is scanning for available terrestrial services, T and T2. While it's doing that, it's also scanning for available DVB-I service list offerings. As I mentioned, in this case, it's using a service list registry query. It could also use a known URL, or it could use signaling in the broadcast, such as a URI linkage descriptor in the NIT or the BAT. So once this scan is finished, the TV is going to show the available DVB-I service lists that it's found, if it's found any. Of course, in this case, we have two, which should be, here we go. So the two lists it's found, we're going to be using the first of these in this demo. So if we select that, the TV will download the list and parse it. So now it's parsed it, and it's found that there are in fact two regions. Each region has its own channel list, so that allows targeting of services. We're going to be picking the second one here, Piemonte. So now the installation is complete, and the TV is going to tune to the first channel in the channel list, so channel 4 here from Mediaset. So let's just switch through some of these channels here. So let's go from channel 4 to the next one, channel 5, and then channel 6. So you can see it's a typical linear TV experience, except here channels 5 and 6 are in fact delivered using DVB-, and channel 4 is delivered using T2. So thanks to DVB-I, you can see they're all incorporated into this single linear TV service offering into a single service list without any particular difference between them. Looking more in detail at DVB- services, so here we're going to switch through a series of channels delivered using DVB-. What you may notice is that the switching time between these channels is actually quite short. There are two main reasons for this. The first is that the TV supports DVB- natively. So it doesn't require an additional application to start Dash playback. It can hand the Dash manifest directly to its native Dash player. The other reason is that some of these are low latency Dash services, which further helps to reduce the time needed to start playback. So there we've seen an integrated linear TV experience with broadcast and broadband delivery into a single service list. Let's have a look at that in a little bit more detail before we end the demo and bring up the channel list itself in the TV UI. So you can see, yeah, here we go. So on the right-hand side, here that integrated channel list with those first 4 Italian services from Mediaset that you'd find in a typical Italian installation. And then in the 850 plus overflow range, you've got the demo services there. All this information, of course, is part of the DVB-I service list XML, the channel names and the numbers, the LCN allocation, together with the information on delivery, so the manifest links and the DVB triplets that allow the TV to map between the information it's found in the terrestrial scan and the information from the DVB-I service list itself. So we can see that DVB-I is real benefit to service operators. It can allow them to combine both broadcast and broadband, and by doing so, get the most out of both of these different delivery methods. And by doing so, they may be able to offer a wider range of services or higher quality services that really take advantage of the latest features in client devices, such as UHD, HDR, or next generation audio. And of course, viewers benefit from this. They get improvements in quality and a wider choice. All of that without compromising on the linear TV experience, including the channel change time and responsiveness. So thanks for listening. And if you have any further questions, please get in touch this afternoon.
Thanks, Nicholas. Indeed, people can book now a meeting slot with you and your colleagues at TPV this afternoon. Tell me, why is DVB-I important for TP Vision?
Yeah, I think there are 2 main reasons for that. The first is that it will allow us to offer a wider range of linear services, so improve the services we can offer to our customers. And I think the second reason is regarding the user experience. Today, often to access different broadband services, users have to use different applications. And while they do a good job, the user experience does change from application to application. And here with DVB-I, that can all be integrated into a consistent user experience.
Yeah, as we've seen in your demo there this morning.
Yeah.
Thanks very much for being with us, Nicholas. It's so good to see all of this momentum building around DVB-I. Of course, one very important part of the DVB-I ecosystem is DVB Dash, and that is the subject of our next contribution, where I am joined by Rufael Mekuria, who should be with me on the line there. Rufael, good morning.
Good morning, Owen. Thank you for the introduction. So I'm going to talk a bit about DVB Dash, and in particular live stream generation. So we will present some tools and architecture for creating live streams. And also, since early this year, I have been chair of the TM Stream group. And we have also used some of these tools to contribute some reference streams on low latency and targeted ad insertion to this group as well. So this is a joint work with some of my colleagues, Arjen Wagenaar, Mark Obel, and Simon Westbrook. So let's dive into it. So we got Nicolas' interesting presentation from TP Vision. But when you are generating DVB Dash for DVB-I, you're typically generating live streams. So the CDN cost of live stream is typically lower because users will watch the same content, but you need a good and a fast CDN interrupt. Good live encoders can be expensive. Then handling the key rotation and encryption for live can be challenging. Then doing the ad insertion like in real time in the low latency can also be challenging. And then often you will need to support both DVB Dash and an HLS specification. And most importantly, if you are streaming live content, failure is really not an option because DVB Dash uses the internet and broadcast, it's still prone to failures. So you need to have an architecture in place where you can basically have backup segments in case there is a failure. And then also, low latency and end-to-end workflow is also challenging. While that's typically what you want to use in a DVB-I setting. So we have developed some architectures and tools for this. So basically we have two sides. So we have worked in the -IF to standardize a CMAF live ingest. So that's basically an interop protocol from a live encoder to the CDN or the origin packager. And we have a demo of VOD to live, where you can basically convert a VOD asset to live, when you can basically sidestep much of the problems associated with the live workflow. So you can basically convert a VOD stream to a low latency live stream. And then we have done work on DRM support and support for third-party ad insertion, which I'm going to show in this demo. So basically, so as an input, we are using, what is important to mention is we're using standardized formats. So as I mentioned, we're using a standardized live ingest. If you're using a live encoder, we're using a standardized storage format based on DVB- or CMAF. When you're using a stored asset, we use time metadata based on SCOTI-35 or SCOTI-214. We output DVB- HLS, smooth streaming. We integrate with third-party ad insertion services, and we use standardized DRM based on common encryption, which is the all industry standards. So that's basically our flagship solution, which is called Unified Origin. So it's an Apache web server plugin, and it supports most of these features. So with Unified Origin, from a VOD asset or a live ingest, you can basically generate a low latency DVB- stream that is prepared for also for ad insertion and encryption. So we have used these tools to create also some test content to allow some of the DVB members, such as TV manufacturers, but also operators to test some of the streams. And in particular, we have also integrated with ad insertion solutions such as Amazon Media Tailor, but also we have our own methods for inserting ads. So I'm going to show some of these streams. So they are publicly available on a test website, and we have integrated both with the Shaka player and Dash.js, but there are also integration with other DVB members such as on-screen publishing. So basically, I'm going to show just a test signal, which is a SMPTE bars. And so this is Shaka player. So it's loading. So basically, we created a test signal with a live ingest. That includes a clock signal, and then we insert SCOTI-35, SCOTI-214 markers to allow either creation of a multi-period dash content or to insert ads. So in this example, we insert ads at the boundary. So with some time, an ad boundary will come up, and an ad period is inserted. So it's a bit boring content, but we think it's good for testing using a SMPTE bars and the clock. And we're also planning to add some subtitles examples to it. So while we're waiting for the ad, I will also so another example of easy setup is with VOD to live. So this is another example to create a very simple test stream that uses a VOD asset that is converted to live. So here you see Tears of Steel, which is played as a live content instead of a VOD content. So in that case, it's also easy to test with subtitles and so on, which are difficult to generate. So here you see the advertisement that was inserted.
You have your robotics, and I just want to be awesome.
So these are some of the examples of the test streams. So again, it's publicly available, so you can check it out.
All right, fine. I'm freaked out.
So if you want to try it yourself, the demos are publicly available, and so is the content. So please, if you want to know more, please book a session with us in the afternoon and look at our website or contact us. Thank you very much.
Rufael, thank you very much for that. We know that there are many different options when it comes to streaming technologies. What for you and indeed for your clients are the benefits of going for DVB-Dash specifically?
Well, I think that DVB is good at serving like the needs of the smaller broadcasters and TV manufacturers. So what we are also active in other standards bodies like SCTE or Dash IF, and there we see that often like the needs of much bigger companies in the United States are very different. So they basically in DVB there is a bit more DVB Dash there's a bit more constraints of how you should build your stream and what a client should do, and that's very helpful like for smaller companies that cannot invest on the technology or don't really want to customize the technologies, which we do see some big US companies like Comcast or Hulu, they like this kind of flexibility that Dash offers. Well, I think with DVB Dash you can really rely on something that is well specified and serves the need of smaller broadcasters that don't have like this kind of pockets, deep pockets.
Indeed, good to hear. Well, if anybody would like to talk to Rufael more about DVB Dash and about unified streaming, you can join him this afternoon in our meeting rooms. Thanks to Rufael for joining us this morning. Now, next up, we are talking about advertising, targeted advertising, and we are going to be joined by Verance Technologies, and Jason Patton is with us. So let's see what Jason has to say.
Hi, my name is Jason Patton, and I am Senior Vice President of Sales and Marketing for Verance Corporation. We're based in San Diego, but we do business all over the world, and I am frequently found in Europe as well. And what I'd like to do is introduce you to our company and our technology. We do watermarking, audio watermarking, video watermarking. We've been in business for the past 25 years, and right now we're in an exciting time where our watermarking technology has been included in the Next Gen TV, also known as the ATSC 3.0 standard in the United States. And then HBB TV has adapted that same technology for Europe and the rest of the world. And then we're also seeing this watermark technology be a key portion of the DVB-TA specification. And what does this Verance Aspect watermark technology do? What do we do in these ATSC 3 standards, the HBB TV standards, and the DVB-TA standards? The key thing that this watermark is able to do is pass through the HDMI port. And so many television experiences today involve HDMI. Throughout Europe, there are many different instances where a set-top box is a key part of the distribution chain to getting a video signal to the end viewer. And in those cases, interactivity, addressable advertising can't work seamlessly. But by including an audio watermark inside the audio of a video broadcast, or including a video watermark inside the video signal of a television broadcast, you're able to tunnel through the HDMI and provide the same experiences that traditionally exist over the air via digital terrestrial to all those consumers who are using set-top boxes and either satellite or other distributions that involve a set-top. So we're very excited to bring that technology to bear. It's deploying now. Over 20 broadcasters in the United States are sending out our watermark throughout different broadcasts in America. And we have been in trials throughout Europe as well. So if you're interested in learning more about our technology, let's get started first here with a showcase of how the technology works with addressable advertising. The following demonstration will walk you through how the watermark enables TA, it does it seamlessly, and even in a more difficult scenario like a trick play scenario, how the watermark provides a very smooth experience. Now let's take a look at Verance's dynamic ad replacement system with Aspect. You put this together, in the bottom right you'll see this station has no watermarking. Then the orange shows how fast a video watermark is ascertained as well as an audio watermark is ascertained. Now an example of a secondary audio program.
Estuvo ahí cuando el último tipo desapareció.
¿Un testigo?
Sí, un testigo.
¿Y por qué no lo había mencionado?
Felicitaciones, María.
You just saw a targeted ad replacement with our system. Again, the bottom right of the aspect-enabled TV shows the audio watermark and the video watermark. VWM means that you can tell that the video watermark is being detected, and the AWM means you can tell that the audio watermark is being detected. The two of them work in tandem to make sure that targeted ad replacement works well.
Oh, you look good.
Thank you.
And then they can also make sure that things like pause, fast forward, and rewind all work together seamlessly for the viewer. In some cases, you won't have audio. This way, the video watermark makes sure that everything tracks. In other cases, you might not have video, and the audio ensures that everything tracks.
Back so soon?
Here you go, sir. Because the dad's got to do sir, here you go.
This is a fully functioning system that we're ready to deploy throughout Europe, throughout the world, and we're excited to bring this to market.
Back so soon?
Hard to be an eco-warrior.
And you'll see here with the program guide, the audio watermark makes sure that everything tracks. So again, we're very excited about the ability to do targeted ad replacement seamlessly, smoothly, and provide a customer experience, a viewing experience that is really perfect for the viewer. Verance.com/addressable advertising for more information. Thank you so much for taking the time to watch our demonstration of targeted advertising and how the audio and video watermarks that are part of HBB-TV and DVB-TA enable these technologies to work smoothly going forward. If you're excited about this, please take time to find me between 1600 and 1800 today. I'm doing select meetings with people. If those times don't end up working, let's sync up offline. Here's my email, jpatton@verance.com, and I'd be happy to link up at a time convenient for you to discuss all the exciting things that we're putting together with the HBB-TV system, the DVB-TA system, and how they can all work seamlessly together to provide things like targeted advertising, interactivity, measurement, so many different possibilities. So let's connect. Thank you to Jason Patton and his colleagues at Verance. And indeed, Jason will be marking Thanksgiving by getting up very early to speak with you in our meeting rooms this afternoon. So please do book your appointment with Jason now. Now, the last but not least slot goes to our colleagues from Via Access Orca. I am joined by Nicolas Delahaye, who is here to talk to us again about DVB targeted advertising. Good morning, Nicolas.
Good morning, everyone. Okay, so thanks, everyone. So indeed, we worked on a targeted ad project with Orange Belgium, Proximus, and Comscope on a DVB-C broadcast environment. As a quick intro, the Access Orca deploys solutions to address digital ad insertions, both client-side and server-side, with different partners. For instance, on OTT, we deploy a server-side solution with Broadpeak in Asia. But for broadcast environment, it's quite a different story. So I hope most of our guests are not too angry and will enjoy the short presentation we made for this DVB 2020 virtual event. Okay, so following this quick intro, let's deep dive to the topic. And as a teaser for this afternoon, I would like to start talking about the main business challenge for targeted ad, how to reach two worlds. On one side, advertiser one, seeking for 100% reach. On the other side, viewers one, experiencing video services on many different devices, such as mobile, set-top-box, smart TV, or web browsers. To get the maximum revenue from targeted ad, both worlds must be reconciled. Our targeted advertising solution is primarily addressing this challenge and is made on top of 6 pillars. I will introduce 3 first ones. Feel free to pass by our virtual booth later today. We will be keen to explain all the insights. First, having a complete inventory solution. Inventory describes all the materials for ad impressions, such as ad servers, user profiles, and content where to insert, replace ads. Second, mastering viewing experience. It's about maximizing new ad revenue without impacting churn rate. especially if user gets too many mid-roll ads. Our V-Access Orca solution gives our customers a broad set of features to control impression policies on different use cases, such as live, VOD, or time-shifted viewing, like catch-up or LPVR. On top of standard pre-roll, mid-roll, live ad replacement, we are enabling more advanced features, such as banners that are much more accepted by users, or event-based ad, I mean rendering an ad when the user clicks on resume video button. It's a kind of magic pre-roll. The third one is about creating good segmentation. Thanks to broad TV platform data, as well as advanced AI algorithms we developed, the Access Orca solution can create actionable segments, such as young family or sports lover. By combining all these assets, our targeted solution can create new revenue streams to our customers, and more important, protect their valuable TV data and customer assets from giants. The demo we did with Orange Belgium, Proximus, Comscope, on a broad set-top box featuring Android TV demonstrate a client-side live ad replacement on broadcast DVB-C channel. Our OTT players for mobile and set-top box is already deployed on more than 30 major customers, and some are embracing new ads revenue with our full SC35, VAST, and VMAP support. But here, the challenge was different. Replace the second ad in a pod from the broadcast DVB-C stream by a targeted one from OTT without any visual impact, blank frame or buffering. Watch out the transition. What a perfect smooth stitching, isn't it? To solve this complex challenge, we address 4 tasks. Perform a complete integration with the Android TV framework. Use a player to supersede Comscope DVB middleware in order to control DVB streaming, playback, and extract SCT markers from the live encrypted stream. Initiate a standard VAST request by commanding markers, data, and user information to get the targeted ad. And finally, perform pixel scopes and bitcoining in order to monetize impression and trigger different wrappers and ad servers. With this short video, we replace the original ads by a family car or a young baby one, depending to the user profile associated to this segment. Okay, so moreover, if you still have time after visiting our booth later today, I would like to advise you to also spend some time on our key partner virtual booths available today, such as Broadpeak, Harmonic, Atem, and ENENSYS. We worked hard together to perform truly impressive demos showcasing their great piece of technologies, as well as our player capabilities on multicast ABR, HEVC, low latency, and other dynamic ad insertion demos. At last, I hope this teasing will encourage you to visit our virtual booths later today. The demo is quite impressive, and as a sum up of our end-to-end addressable TV solution bridges the 2 worlds. The advertiser one with our inventory, viewing controller, and data segmenter, as well as the end-user one with our player solution, featuring multi-devices and enabling client-side and server-side ad insertion and hybrid mode. Thank you, and see you later.
Nicolas, thank you very much. Our final exhibitor for this afternoon in this DVB Demos live stream. And as you said, you and your partners, and I know you cooperated with many of our exhibitors, have done some truly impressive demonstrations for us this morning. You finished your demonstration there talking about the hybrid case. Can you tell me a little bit more about that, please?
For sure. So hybrid mode is the combination of both client-side and server-side ad insertion. We see many actors opposing both cases, and we believe it's a wrong debate, as they are both required to maximize advertising revenue. For instance, server-side ad insertion could be very effective on a linear replacement on OTT distribution. And banner insertion or linear ad insertion on broadcast mandate client-side ad insertion. Such innovation is possible thanks to strong standard bodies, such as IAB or DVB, which create strong and rich specifications to keep many options open.
Indeed. Here's to strong and rich specifications. Thank you very much, Nicolas. Don't go away, for we are going next to DVB's Head of Technology, Emily Dubs, who has the difficult job of tying everything that we have heard this morning together. Good morning, Emily.
Good morning, Owen, and thanks for the introduction. And first, special thanks to our 14 participants for their hard work and their determination to overcome the many constraints imposed by COVID-19 phase 2. It's amazing to witness such a resilience. I mean, all the people you've seen are just working from home, and together with other colleagues also working from home, they drive innovation forward. Some of them even triggered new partnerships to achieve some of the results you've seen this morning. I'm sure that you agree that in the absence of trade shows, this is really a challenge, because the activities around innovation are usually the first to suffer from a crisis. But also I think that this crisis is different somehow, because especially for our industry, because it's also an opportunity for broadcast and for a reliable media delivery over internet. So I'm sure that the companies that can keep pace in this area will be finally rewarded. So congrats to our 14 participants, and I'd like to mention also 15 participants you've not seen this morning, who is SES, who did also a great job, but finally had to pull out due to the impossibility to access equipment. And in particular, this gorgeous 8K screen on which you would have seen how DVB-I again brings together today's and tomorrow's satellite into a hybrid but seamless user experience. But for sure, you will see this one day soon. So I hope that those demos provided new insights into DVB's next generation specifications, and especially their value for the market. To conclude this morning session, I would like to say a few words about this, about how DVB foresees this IP-centric future and how our solutions address the related needs. So of course, we all know that this future is all about IP. But I believe that this will be a very long journey, and an ideal world is not a world without broadcast. It's a world where an intelligent use of the unique characteristics of both broadcast and broadband networks will finally enable a new wave of innovation and growth for both broadcast and broadband stakeholders. So DVB is creating a hybrid experience where IP services will be delivered seamlessly through a number of access networks. This means that IP services can be delivered through classic DVB networks or any form of broadband networks. That could be, for instance, 5G or a standard fiber connection or any type. So it's a journey, and we'll get there through hybrid networks and seamless hybrid experience based on the overall DVB-I package. This is DVB's next mandate, to build on its success that we all know, to again bring together the industry into a consensus and tackle this next big move. And this move is about IP and unification. And to get there, our rise to that future IP-centric but hybrid and unified media delivery landscape, there's a number of underpinning requirements on which our members are focusing. An important one is to ensure commonalities on the service layer, regardless of how the content gets to people. Also key is a unified and simplified user interface that offers a broadcast-like experience that aggregates all content and results in the consumers being finally enabled to recognize the distribution bearer. Also, there must be agreement on an optimized streaming format and a mechanism that provides a way to scale broadband networks so that their reliability can be on par with broadcast. And there must be also a mechanism that allows service operators to offer personalized content to enhance viewers' engagement and thus also to secure their revenues. So there would be actually a much longer list, of course, but it's just to give you an idea of what's driving our current work, which is being implemented and that you have seen today. So now, more concretely, all these general requirements are translating into specific solutions. At the center of all this is DVB-I, which is breaking down the barriers between broadcast and broadband worlds from the end user point of view, because it offers a means to integrate all kinds of services in an all-in-one service layer that will also ensure, for instance, that a 5G broadcast bearer can carry DVB-discovered services. DVB-I also allows operators to deploy common services across a much wider range of devices, and it allows to improve the visibility of their offerings, also to reduce the need for expensive dedicated integrations. So in that way, it's also the antidote to the issue of apps and video services fragmentation, which is, by the way, another key battleground for our industry. I think that we've heard quite a lot today about that, so there would be a lot to say, but I need to move on. So there's also this new native IP work that has been launched this year that focuses on a solution to deliver native IP streams over broadcast means. This is really important too. It's perfectly in line with DVB's overall direction. So for this purpose, a new group has been created to address the related market requirements. So I strongly encourage any organization with an interest in the future to join and contribute. Or if you're not a member, by the way, maybe it's time to consider it. If, like Google, you don't want to let the future be shaped without you, just join and be part of this big move. Now on the delivery mechanism itself, DVB- is an optimized streaming format that also enables low latency and reduces the discrepancies between broadcast and broadband zapping times. As to DVB-IR, it's a way to enrich and manage networks with the scalability and thus reliability of broadcast. Using combination with DVB-I service discovery, for instance, it can empower substantial optimization for OTT operators around the delivery of high-demand content. Finally, you've also seen some early implementations of the new DVB-TA specification that really offers new prospects for broadcasters because it gives a way to counter the revenue losses thanks to more impactful advertising campaigns. Also, it allows a way to offer personalized content, which is also a must in this internet age. And as you have heard also from Harmonic, there are new applications being added currently that will enable targeted advertising also for DVB-I services. So all those are hot topics for which our members are joining forces with a view to building this unified IP-centric world. If you'd like to know more, please come this afternoon and discuss directly with the members who are implementing the solutions. I will be there, so of course, and I'll be glad to answer any questions, as well as my colleagues from the project office, of course, Peter McAvock, our DVB chairman. You'll see there also Desiree Gianetti and Eva Markborg for any matter around membership. My final thanks go especially to my colleagues from this tiny but great project office for their support in organizing the event and in particular the last minute issues they could fix. And special great thanks to Owen O'Sullivan, our presenter and DG today, who managed to alone mix our faces and screens and interview all of us in a so smooth and professional way. Thanks.
Thanks, Emily, and thank you for your presentation. It's so good to see these different parts all coming together and how they fit together, because I think this is a vision that has been in the making in the DVB project for several years now. But sometimes it's hard. It seems quite fragmented sometimes when things are just starting out, but it's really coming together now. And I think this morning with this event, we have seen the fantastic momentum that's building around this DVB-I ecosystem and all of the different constituent parts. So it's been really good, and I think we're very optimistic about the future. So before we finish up, I do have one last thing to mention, which is that Emily mentioned her name there already. Our colleague Desiree Giannetti is actually years here. She has become part of the fabric of DVB, and I know that when I first joined the DVB project in 2004, had the pleasure of sharing an office with her for 5 years. We had great times together, and anybody who has worked with Desiree, whether on meetings, on events, on trade shows, conferences, down through the years, whether here in Geneva or in Amsterdam or elsewhere at all of the different DVB World locations around the world, will join me in saying thank you to her, wishing her well for the adventures that lie ahead of her. She has exciting plans, but that's for her to tell you about in due course. So we just want to say thank you to Desiree from everybody in the project office and from everybody at the DVB project. It is time for us to say goodbye to you. Please do book your slot for this afternoon. We will be opening the room just before 2 o'clock, and we will move you into the relevant meeting rooms for your slots. So you do need to take that first step of getting your link from Zoom. That's a shortcut to Zoom there, dvb.org/demos2020-register. That link is on the landing page for this event as well. And you will then receive the link to dvb.as.me, which is Acuity Scheduling, where you can book your appointments. Now, the appointments are limited. If some of those rooms fill up, we'll do our best to open additional rooms, but it depends on the availability of staff, which of course is not that easy during this difficult period that we're in. So with all of that said, I'm just going to play one last little video here to say goodbye to you. Thank you to everybody who joined us this morning. Thank you to all of our exhibitors. Thank you to you for following us online, and we will talk to you again. Stay safe.
DVB is a collection of companies and people that believe that if they work together, they can do great things.
So companies can choose whichever DVB standard is best suited to their needs. And in all cases, DVB offers the best technology possible.
No one knows for certain how the media delivery landscape will look in 10 or 20 years. But as DVB members, we will be ready for whatever happens.
Right from the start, DVB recognized that the media industry needed commercially successful standards. So before any work starts on writing technical specifications, DVB seeks and agrees commercial requirements. That simple premise is one of the pillars that makes the DVB project successful.
So it didn't make sense to have separate organizations specifying systems for satellite, terrestrial, cable, and IP delivery, because in the end the services were going to end up on the same TV sets in front of the same viewers. So it was only logical to have the maximum possible commonalities between the systems, and it's only DVB that has done that.
You can see technology evolution in media as being like a train that's always moving forward. If a media company wants to stay relevant in the modern world, it needs to be sitting up front with the engine driver. In DVB you are always with the driver, examining the challenges and opportunities ahead. Right now, we see that broadband delivery and hybrid systems are quickly coming down the track, so DVB's work is very much headed in that direction.
DVB has members worldwide. We currently have some 25 work groups actively studying new ideas, preparing the commercial requirements and then the specifications. But there's much more. We have an annual conference, we have promotional workshops, and we have a lot of other ways to ensure that our members know what's happening in DVB.
We're in a transition to a personalized media experience based on both broadcast and broadband delivery. There's a lot to do. Come and join us.